All right, so keep on working backwards. We have some triangle called ABC. C is the right angle. And I'm told that little a is 2/3 and C is 1. All right, so if I want to find little b squared plus 2/3 squared must be 1 squared. So b squared is 1 minus 4/9 because 2/3 times 2/3 is 4/9. So b squared is 5/9. This makes b √5/3. All right, that's easy. That's an exact value. All right, now, the other two things I need is I need to know the measure of angle A and I need to know the measure of angle B. And this could be anything. For A, if I wanted to, I could say it's the arc sine of 2/3. I could say it's the arc cosine of √5/3. I could also say it's the arc tangent of 2√5/5. Now, how would I do that? So think about the tangent of A. It's opposite over adjacent, so 2/3 over √5/3. Threes cancel, and I get 2 over √5. And I know you guys know how I come up with stuff like that. We multiply top and bottom by √5. And I could do the same thing for the measure of angle B. I could say that the arc tangent on it is going to be √5/2. I could do arc sine of √5/3, or I could do arc cosine of 2/3. So who knows what I pick? But I can do one of those. I can do anything I want. It's my freaking problem, right? So I can do anything I want to do. 5 is something I made up. Let's see if it actually does anything. To what does secant of x minus cosine of x simplify? Well, secant is 1 over cosine. And we're going to take away cosine over an understood 1. So we're going to multiply this guy by cosine over cosine so that I can ultimately have a common denominator, because that's going to make this denominator cosine of x. And cosine times cosine is cosine squared of x. Last I checked. So what I end up with is 1 minus cosine squared of x over cosine of x. So not all of you have been writing this down, but most of you have. Sine squared plus cosine squared is 1. So if I subtract cosine, I get that sine squared is 1 minus cosine squared. So this gives me sine squared of x over cosine of x. Now I can break that apart into sine of x over cosine of x times sine of x. And that becomes tangent of x sine of x. So that's what that reduces down to. Give me just a minute, my wife's texting me. All right, last three. You know, when I looked at this thing about 3 weeks ago, for some reason, it just never occurred to me what to do. And it just bothers me that I didn't. But anyways, I can divide out the 5. I guess I had never, and that's part of it, on the spot, I'd never been asked to do a problem like this. But so let's go through what you do. It's actually not that bad. And it's going to seem kind of funny, but I'm going to convert to a log. I'm going to actually just ln both sides. So I'm going to have an ln here. I'm going to have I done lost my train of thought. I'm sorry. I'm going to have an e to the 2x plus 3 all over 5. And over here, I'm going to have an ln of e to the x. All right, I'm going to break this logarithm apart. This is the ln of e to the 2x plus 3 minus the ln of 5. And on this one, I know you don't remember this, but what power of e creates e? It's 1. I get just x. And let me pause this because my wife's still messaging me. So I just spent like 10 minutes doing 1 through 3 and I never actually hit resume record. Oh. Anyways, I realized that this problem was flawed. I'm going to make it a negative 6. And what I'm going to do is I'm going to move everything to the left in kind of a standard form. Now, believe it or not, if you take an e to the x and you multiply it by an e to the x, you get an e to the x plus an x, which is e to the 2x. That's kind of cool. I've done this with y'all before. I'm going to use a technique called substitution. I'm going to let, and I'm going to pick a different letter here. Let's just say u is e to the x. U squared would be e to the x squared, which is e to the 2x. So u squared minus 5u minus 6 is 0. It's called u substitution. I can factor now. And if I use the ZPP, I get that u is 6 or u is negative 1. Now u was e to the x. So e to the x is 6 or e to the x is negative 1. Now there's a lot of kids who think that you can do something with this equation right here. It is 100% impossible without using imaginary numbers to take a number that's positive and make it negative through the exponential space. You always got the kids like, what if I use a negative? Ha ha, I'm so smart. It just makes it smaller because it makes it a fraction. What if I use a fraction, Milbrath? What's that going to do? Well, it's just going to find a particular root. So like if I want to take the cubic root of e, it's not going to make it negative. It's just going to generate a smaller number. This thing ends up being nonsense. And if you don't believe it's nonsense, you'll come across it sooner or later. You will maybe convert to a logarithm base exponent argument. We'd have a log base e whose argument is negative 1 equals x. And at this point in time, you should have quit because this is not defined. And by the way, that's the natural log. But if you haven't gotten there so far, you will go to your calculator and type natural log of negative 1, and it will legit say error non-real. Non-real. I told you there's some answers that works, but there's no real answers that work. So that's off the menu. All right. Oh, God, I hurt. Let's do the same thing over here. We have a base, we have an exponent, we have an argument. Log base e is called ln. Argument 6, that equals x. There's the one true answer, number 3. Number 2, there's 2 ways of doing this. It is asking you what is the cotangent of an angle whose sine ratio is negative 1/2. So the classic way of doing it, and the way most people do this, is to actually go, hey, this is negative, and this is arc sine, and they say it's either 1 or 2. And what they do is they just draw themselves a triangle in quadrant 2 with the right angle formed with positive x-axis. Now the sine ratio is opposite over hypotenuse. A little Pythagorean theorem is going to get you a root of 3 there. That's -1 squared. I'm sorry, that's 2 squared minus a squared equals 2 squared minus the -1 squared. And that's going to get you root 3. And think about your angle being right here. The cotangent ratio is AO. So you'll get root 3 over -1, which is just -root 3. That is by far probably the most popular way. I'd say 9 in 10 people approach a problem like that from that aspect. I would say they do. Okay, the other way of doing that is to realize that this is going to be the angle 330 degrees, because on the unit circle, you're going to be right there. You're going to be at a y value of -1/2. The x value there is root 3 over 2. And when you do your circular approach, the cotangent of an angle is x over y. So you would take root 3 over 2, you would divide it by -1/2, the 2's would cancel, and you get root 3 over -1, which is still -root 3. Any way you spin it, you get the same thing. All right, and here comes number 1. To what does 1 minus the cotangent of x over 1 minus the tangent of x? Simplify. Oh. Well, let's just rewrite things in terms of cosine and sine. It's a valid strategy. So, cotangent's cosine over sine, tangent is sine over cosine. And what I'm going to do is I'm going to take that 1 and put it over 1, and I'm going to give it a sine of x here and a sine of x there. So it's going to become sine x minus cosine x, both pieces over sine of x. And we do the same process down low. This is going to become cosine of x minus sine of x, both pieces over cosine. All right, now we're going to go back, and this is legit, 5th grade content just with trig. It's not bad. To divide one fraction by another, one would multiply by its reciprocal. So we're going to multiply by cosine of x over cosine of x minus sine of x. Now, if we focus on this, that's cosine of x over sine of x, which is cotangent of x. Last I checked. Now I'm not going to worry about that anymore. I'm going to focus on this, sine of x minus cosine of x over cosine of x minus sine of x. And I see it, maybe you see these guys are awfully close. If you pull the negative from sine of x minus cosine of x, the cosine becomes positive and the sine becomes negative. Cancellation. We get the -1, full simplification, negative cotangents of x. And that is your twin.